Hello! Today we're talking about circumference and arc length. So this is 16.1a, I'm calling it because we're only doing half of it, and then 16.2 out of your textbook. And the essential question is, how do I calculate the circumference and how do I calculate arc length? So go ahead and pause if you need to get your notes set up. Just a reminder, all this stuff, including the table of contents information, is on your assignment sheet. So to begin, we need to talk about what circumference is. So hopefully some of you remember, but circumference is kind of the length of a circle. Keeping in mind the circle doesn't include the inside. A circle is just kind of the line that you draw when you draw a circle. So I'm going to draw a circle using this stencil here, and I'll start up here. And as I go around, I'm creating the circle, and the length of that line that I drew, or really curve or circle, is called the circumference. So it's the distance around the circle from a starting point back to that same point. And it's hard to calculate because it's not straight, right? So I can't just count the number of boxes, it's curved. And so calculating the circumference requires a formula. We can't just guess. But let's go ahead and take a minute and define circumference. So circumference is the distance around a circle measured as length. So we're talking about, for example, we might measure it in centimeters or in inches or in feet or in meters. Something like that. So it's length. And I like to think about it as, if this was if you could miniaturize yourself and become really tiny and you walked around the circle, how far would you be walking? That's what circumference is. And so to calculate the circumference, we have this handy formula. Circumference equals 2 times pi times the radius. And you'll usually see it just as 2 pi r, which means 2 times pi times the radius. So this is our first time seeing pi, which is my favorite number, and maybe I've told you why, but I'll remind you again in a moment. There's another way to write the circumference, which is pi, well, I'll start with d times pi, okay, the diameter times pi. And it's worth taking a minute to think about why these both work, right? D stands for the diameter, R stands for the radius. But if you do 2 times the radius, you get the diameter. Okay, so 2 times the radius times pi is the exact same thing as the diameter times pi. And you can use whichever one of these formulas is most convenient for you. So if you're given the diameter, you might want to use this bottom formula, and if you're given the radius, you might want to use this top formula. So let's talk about pi for a minute. Pi is a Greek letter. It's not yum yum eat. It's actually spelled P-I. It's kind of like the Greek letter P. Okay, so pi, which looks like that, it's a Greek letter, is approximately equal to 3.14. And the reason it's my favorite number is because my birthday is March 14th, 314. So on March 14th, we will have a big celebration because it's Pi Day. Maybe we'll eat pie. This number goes on forever. So 3.14, that's as far as I have memorized, but there are a lot of nerds who have a lot more of that memorized. But for our purposes, normally when we need to approximate pi, we'll just use 3.14. There are other approximations though, so pi is also approximately equal to 22/7. So you can see that if I take my calculator and I do 22 divided by 7, you can see I get pretty close, 3.14, and then it diverges, but you can see that it's pretty close. It's more accurate than 3.14. Your calculator also has a pi button, so if you hit the pi button, it's right here, and you just hit enter, there you go, 3.14159.265, it should actually be 3.5, but your calculator rounded. So lots of ways to approximate pi, but we can't write down the entire number because it's an irrational number. So let's go ahead and do some example problems. Oh, one thing you might want to do on this beautiful circle, sometimes I like to just write circumference like this to just remind myself that circumference is going around the circle. So we're going to do, I think, 2 examples to practice circumference. So example 1, we're going to talk about a Ferris wheel. A Ferris wheel has a diameter of 40 feet. And I want to know, what is the circumference? Okay, so I'm just trying to write less by writing c equals blank. So what is the circumference? So we're going to use one of these formulas, either this guy, 2 pi r, or this guy, the diameter times pi. And again, you can use whichever seems more convenient given the problem. So in this problem, it's telling me the diameter. It's saying the diameter is 40. So the very first thing that I'm going to do here is write d equals 40. So I'm just kind of building the information that I have in the problem. So d equals 40. So I'm going to want to use this bottom formula, the diameter times pi. So I'm going to write the formula, c equals d times pi. And then I'm going to replace the d with 40. So circumference equals 40 pi. And sometimes it's okay to leave your answer like that. This is the only way we can write our answer in an exact way. So 40 times pi. But it's also okay to approximate, and your book is going to ask you to usually to use 3.14 for pi. So I'm going to do 40 times 3.14, and I get 125.6. It's important that we use these squiggly lines to show that this is an approximation. It's not an exact answer. And then we want to make sure we include our units. So the circumference of this circle is 125.6 feet. Okay, so the Ferris wheel, if you were to measure all the way around it, it would be 126 feet long. Let's do example 2. Okay. For example 2, a pottery wheel has a radius of 2 feet. And I would like to know what the circumference is. A pottery wheel is like a flat wheel that you spin and you make pottery, and that's all I can tell you. But if any of you know more about a pottery wheel, then please make me some pottery. Okay, pottery wheel has radius of 2 feet. First thing I'm going to do is write down what I know. So I know that the radius is equal to 2. So when I go back and look at my formula options, I'm probably going to use this one because this one has r, radius. So I'm going to write that formula down. Circumference equals 2 times pi times the radius. And then I'm going to go ahead and replace the r with 2. So I've got circumference equals 2 times pi times 2. And it's a good idea to simplify this. 2 times 2 is 4, so this is the same thing as 4 pi. And this is the exact answer. If we want to get an approximation, then we're going to take our calculator. This time, just for fun, let's let pi equal 22 over 7, just so we can practice doing that. Sometimes a problem will specifically tell you to use 22 over 7. So I'm going to take my calculator, and instead of doing 4 times 3.14, I'm going to do 4 times 22 divided by 7. And that's how you type it in. This fraction bar is just the division sign. And I get a long number, and it's a good habit to round to the nearest hundredth. That's what I'll do. So we've got 12.57. That's in the hundredths place. So we look next door. Since that number is less than 5, we leave the 7 alone. If this was 5 or greater, we would bump that up to an 8. So 12.57 is our approximate answer, 12.57. And then let's make sure we include our units, feet long. So the distance around that pottery wheel is 12.57 feet. So that's the basics of circumference. What we're going to talk about next is arc length. So please draw a circle. Do the best that you can to draw a nice circle. If you don't have a stencil, just do the best that you can. And for this circle, we do need to to locate the center. So do your best to locate the center of that circle. There we go. And we're going to draw in an arc. So I'm going to use my little guy here. I'm going to draw in 2 radii, and it doesn't really matter where they are. I'm going to go here, and then I'll go here. Yours does not need to look exactly like mine, but what I'm going to do here is kind of highlight this arc. Okay, so this arc here is a part of the circle, right? And we've talked about the measure of an arc. So if I measure this central angle with my protractor, that looks like it's about 115 degrees. So I'll write that in, and you don't need to measure yours. You can just write in 115. It's okay if it's not drawn to scale. So the measure of this arc is 115 degrees. So all that means is that moving around the circle, right, a whole circle is 360 degrees. It just means that I'm only moving 115 degrees out of the 360 degrees around the circle to get that arc. But this doesn't tell me anything about actually how long the arc is. So I want to kind of show you what I mean. I'm going to take a smaller circle here, and I'm going to find the center of that circle. And I'm going to attempt to do the same thing. I'm going to draw 2 radii in here, and I'm going to attempt to make it the same measure, so about 115 degrees here. Okay. 115 degrees. And so again, I'm going to highlight this arc that's made from that central angle. And what I hope you can see is that even though these are both 115 degrees in terms of the measure of the arc, they are not the same length because the circle sizes are different. So if I were to take a walk, if I could miniaturize myself and take a walk from here all the way to here, that's a longer distance than walking from here all the way to here. So even though the measures of these arcs are the same, the lengths of the arcs, so these yellow lines, are different. And so to find the length of the arc, we need to have information about how large the circle is. So what we're going to do here is find the length of each one of these arcs. So I'm going to measure in, let's measure in millimeters here. So this first one is about 15 millimeters. And this second one is about 10 millimeters. And again, I know that your circles probably are not an exact replica of mine, so you can just write this in even if it's not accurate. So we have 2 different circles here. They both have the same arc measure, but they have different radii. So I want to find the length of each arc, okay, the length of that yellow arc. So there's a formula that we can use, but instead of giving it to you right off the bat, I want us to really think about how to derive it. So first we need to think about the circumference, right? If I were to go all the way around the circle, how far would that be? So we're going to start by finding the length of the entire circumference by using our formula circumference equals 2 pi r. So I'm going to do 2 times pi times r, and that's going to get me the circumference of the circle. So I'm going to go ahead and do that. I've got 2 times pi times 15 millimeters because that's my radius. 2 times 15 is 30, so I have 30 pi. And I can go ahead and approximate that using 3.14. So I've got 30 times 3.14, 94.2. Okay. So that means that going all the way around the circle is 94.2 millimeters. But the question is, how much is just that yellow arc length? And so what we're basically going to do is figure out what portion of the circle is taken up by the arc length. And the portion of the circle is 115 degrees out of a whole circle, which is 360 degrees. So if I want to know the fraction of the circle taken up by the arc, I'm going to say, okay, well that's 115 degrees divided by 360 degrees. That's the entire circle. So I need to figure out what that is. I'm going to keep bringing that down. 115 out of 360. And then I'll figure out what that is as a decimal. 115 out of 360. Okay, so I'm going to round that. It's 0.3194444, but I'll go ahead and round to 0.3. This is the hundredths place. That 9 is going to bump that up to a 2. So instead of 0.31, it's going to be 0.32. So times 0.32. So I've got to do 94.2 times 0.32. 30.144. Again, I'll round to the nearest hundredths place. So I've got 0.14 looking next door. Since that's less than 5, I'm just going to leave the 0.14 alone. So 30.14 millimeters. So let's talk through again what we did. First, I found the circumference the whole way around the circle, and that was 94.2. Then I figured out what fraction of the circle was taken up by the arc by doing 115 degrees out of 360 degrees, which is the entire circle. So the part to the whole. Found that as a fraction, changed it to a decimal, and then I multiplied the entire circumference by the portion of the circle taken up by the arc. And that gave me the length of that yellow line segment. I'm going to do the same thing over here, only I'm expecting it to be a smaller number because it's a smaller radius and a smaller circle. So this time I'm going to go ahead and give you the formula, and then we'll use the formula here. The formula for arc length equals, oh, I should have said, for some reason, and I don't know why, we use the letter S to represent arc length. So arc length equals m over 360, where m is the measure of the arc, okay, the central angle. So it's m over 360 times 2 pi r. And I hope you can see that this is the circumference, and this is the portion of the circle taken up by the arc. Okay. All right, so we're going to use that formula for this arc length here. So S is the arc length, S equals m over 360, where m is the measure of the arc, so it's 115 over 360, times 2 pi r. 2 times pi times the radius, which here is 10 millimeters. So this, I know this looks super scary and complicated because there's a lot going on. We have a giant fraction, we have the pi symbol, but I hope you can see that this is just the circumference, which we've already practiced, and this is just the ratio of the arc to the whole circle. So the first thing I would do is convert that into a decimal. It's a little less intimidating that way. So I've got 115 divided by 360. And obviously I'm going to get the same answer as I did over here, right? So it's 0.32 is how I'll round it. So the arc length here equals 0.32. So it's about a third of the circle, times 2 times pi times 10, which is 20 pi. So I can do 2 times 3.14 times 10, 2 times pi times 10, and I get 62.8. So all I need to do now is multiply those two numbers together. So 0.32 times 62.8, and I get 20.096. So I'm going to talk about how to round this because it's a little trickier. So after the decimal, I have 9, right? 0.9. This is bigger than 5, which means I need to bump it up. So instead of 0.09, if I bump 9 up, it becomes 10. So it's going to be 20.10 when I round it. So the rounding there I know is a little complicated. So it is, the arc length is approximately equal to, what was it again? 20.10 millimeters. And so sure enough, it is smaller than this one because the circle itself is smaller. So that's today's lesson. I have just a tiny amount of space at the bottom, probably not enough space, but I do want you to take a moment to write your summary because you need to, as soon as you're done watching the video, type your summary in on Google Classroom. So let's write summary. And the essential question here was, how do I calculate the circumference and how do I calculate the arc length? So we're going to turn that around. To calculate circumference, you can give me the formula or you can just explain how to do it in words. And then to calculate arc length, and again, you can give me the formula or you can write it out in words. And the other thing I want you to do is just make sure you go back through your notes and you think about how to fill in the left-hand column. So here we're talking about the definition of circumference. Yikes, okay. And the formulas, so I might just write formulas here. And these are examples. And then down here we're talking about arc length. And then here we have examples. Okay. Oh, you can't see that. Haha. Here we go. All right. So at this point, go ahead and stop the video. Make sure you go to Google Classroom and you type in your summary so that you get credit for that. And then make sure you understand everything we've done here so that you can come to class next time ready to work on your assignment.